Hi, so here we have a problem in which we have to find the area of this given figure. So what this figure actually is. So if we count the number of vertices, there are 1, 2, 3, 4 and 5 vertices, and there are 1, 2, 3, 4 and 5 sides. So what this figure is? This figure is actually a pentagon, right? Yes, but we haven't learned to find the area of a pentagon. So what can we do? We can convert this pentagon into triangles. If I draw this line and this one, now we have 1, 2 and 3 triangles, and now we can find the area of these 3 triangles, and if we add all those areas we will find the area of the original figure, right? But how to find the area of these 3 triangles? Yes, we have our bases in place, but we have to find the heights, right? We have to find the length of all these. And then we can find the area. So I think it is going to be a very long calculation to find the lengths of the heights or to find all the dimensions. Then also you can find the area, but I have a shortcut. I have a very smart method in which we are going to find the area. So now let's see that. I have removed all the construction and I am going to do one and only one construction, which is from point A to point D, right? So this is my construction, and if we talk about quadrilateral A, B, C, D, what it is? See, if we extend this line, I am going to extend this line AB from point B to say point G, and if we talk about this angle, what is this angle? Yes, it will be 90 degree. It will also be a right angle. Why? Because this is 90, this is 90 degree, and straight line minus 90 degree will give you a 90 degree, right? And again, if we consider line DC and AB, and let's talk BC as transversal, angle C, that means this angle is actually equal to this angle, which are alternate angles. And if alternate angles are equal, the lines AB and DC are parallel, right? And a quadrilateral where one pair of lines are parallel, we call it trapezium. So actually ABCD is a trapezium, isn't it? Yes. Okay, so ABCD is a trapezium, and we know how to find the area of a trapezium. And what we have to do next? Let's find the area of that trapezium, and if we remove this area, which is a triangle, and it is a right angle triangle where both the height and base are given to us, right? So we need not to find anything over here, isn't it? So if we find the area of trapezium ABCD and remove the area of this triangle, we will get the area of our original pentagon, right? So now let's first find the area of the trapezium. What is the area of the trapezium? Area of trapezium it is equal to 1 by 2 sum of parallel lengths multiplied by height, right? So what is the length of parallel lines? They are 18 plus 20 these two were parallel lines. This is a parallel line and this is a parallel line, which are of length 18 and 20 respectively, and multiplied by height. What is the height? Height of any point from a line is actually the length of the perpendicular from that point to the line. So in this case, height is actually the length of BC, right? Yes or no? Yes, because from point B, if we draw a perpendicular, it will fall on point C, because this angle is 90 degree, and similarly point C, the length of perpendicular will be BC, because the perpendicular in this case is falling on point B, because this angle is also 90 degree, right? So the height in this case is the length of line BC, which is 12 centimeter, right? So what will be the area? So if we solve it further, we will get 2 ones are 2, 2 6 are 12, and inside we will have 38 multiplied by 6, and this will be equal to 6 8s are 48. So 8 will be written over here, 4 carried forward, 6 3s are 18, plus 4 is 22. So the area of the trapezium is 228 centimeters square, right? And now we have to find the area of this triangle AED. Why? Because that was not the part of our original figure. So if we talk about the area of triangle ADE, it will be half, base is 5, multiplied by height, which is 10, 2 ones are 2, 2 5s are 10. So area of the triangle which have to be removed from this trapezium will be 5 5s are 25 centimeter square, right? So what will be the area of ABCDE, pentagon ABCDE? It will be the area of trapezium, which is 228, minus the area of the triangle, which is 25, and this will be 203 centimeter square. So this will be the area of the pentagon which we were supposed to find, right? Yes. And how have we solved it? Yes, one way was to convert this into 3 triangles and then find the area of those 3 triangles, add them up, and then you will find the area of this pentagon. But in that case, we were supposed to do lots of calculations, right? And then also there was no straightforward method. So what we have done, we have converted this pentagon into a trapezium, and then we have removed the area of this triangle from the area of this big trapezium to find the area of our pentagon, right? Yes. So though this was not a straightforward method, but it was faster and more effective, right?